question 8, we're going to use the same thing from the formula booklet. We can see it's in log format here, so we're focusing on this side. ln natural log indicates that it is base e, and so we're going to have this base, so that's e to the power x, which in this case is 3, equals x plus 2. And to solve for e, we can obviously move the 2 across, so it's x equals e cubed, take away 2. The next one, we have two statements, neither have logs involved, so we can take logs of both sides. Because this side has a 10, I'm going to choose to take logs base 10. So we just have to write the word log for base 10 equals log 500. We can bring the 2x in front now because that's a power. We know that log base 10 of 10 is 1, so that's gone. And obviously we're going to divide by 2 now, so we've got x equals log 500 divided by 2. Now on to the calculator question. Unfortunately my smart view for the calculator isn't working at the moment, so I'm going to show you the working and then you can find the actual answers using your own calculator, so I apologise for that. Find the initial number of bacteria in colony A. So if this is the formula for colony A, the initial indicates that T is going to be 0. So we've got 12 times e to the 0.4 times 0. We know this is obviously equal to 1 because anything to the power of 0 is 1. So we get a value of 12. And the number of bacteria after 4 hours. So we're going to put T is 4, so it's 12 times e to the 0.4 times 4. You can just put that straight into your calculator. And so I'm just referring to the answers. You get a value of 59.4363. In these cases, application questions, you have to think carefully about your rounding. Because we're talking about bacteria, you can't have a decimal portion of bacteria. We haven't made it to 60 bacteria, so our final answer would be 59. It did specifically say on the mark scheme that it had to be an integer value. How long does it take for the number of bacteria to reach 400? So this time we're trying to establish the value of T. Let's just get rid of this. So we set our equation up of 12 times e to the 0.4 t has to equal 400. Because our unknown is in the power, we know we're taking logs, but we cannot take logs with the 12 here, so we need to move that first. So it's e to the 0.4 t equals 400 over 12. Take logs of both sides. We're taking natural logs because we have base e here, and at the same time I'm going to bring my power in front. So I've got 0.4 t ln e equals natural log of 400 over 12. ln e we know is equal to 1. So t would be natural log of 400 over 12 divided by 0.4. Again, referring to the answer sheet, I have a value of 8.76639. In SL course, we always run to 3 significant figures, so 8.77. On to the next question. There is a new model for this one, so we've got 24e to the kt. We're told that after 4 hours there are 60 bacteria, so we can substitute those two values in. So we've got 24 times e to the 4k equals 60. Similar situation, our unknown is a power, so we're going to have to move the 24 first. So e to the 4k equals 60 divided by 24. Again, take natural logs because it's base e. So we've got 4k ln e equals natural log of 60 over 24. This is equal to 1. So k is natural log of 60 over 24 divided by 4. And that gives an answer of 0.229 to 3 significant figures. Again, rounding to 3 significant figures is important on the SL course. So final question, it says we need to find when the colony in A first exceeds, so that means is greater than the number of colony in the number of bacteria in colony B. They've said where n is a member of Z. Remember that the Z indicates it's an integer, so we're trying to find a whole number value for n. It's always a good idea to try and summarize what you're trying to look at. So we know that we want the colony A bacteria, which is given by 12e to the 0.4t, needs to be greater than the colony B formula, which was 24e to the 0.229 p. The 0.229 was the value we just calculated. Different ways of doing this. To be honest, I think the easiest thing is just to find some values. We can see from the previous question that we actually have the number of bacteria at 4 hours for both of the colonies. So we know that colony A at t is 4 was 59, and for colony B we were given the value of 60 after 4 hours. So we know that this was 60. Well, clearly 59 is not greater than 60, so it's not going to be when t is 4. So let's try when t is 5. So we've got 12e to the 0.4t. Oops, sorry. Putting in 5. 0.4 times 5. We need to see if that's greater than 24 times e to the 0.229 times 5. And I'm just referring to the answers here. For this one, we should get a value of 88.668. And for this, we should get 75.446. Clearly, 88 is greater than, so we're looking at the value of t as 5. Sorry, apologies, n in this case would be 5 is our final answer.